Hello everyone, welcome back to my channel. Today I am going to discuss about how to implement logic gates using 2x1 multiplexer. As we know, 2x1 multiplexer that selects one of two input signal and passes through the output based on a control signal. But did you know that we can use muxes to implement logic gates too? Yeah, let's get started. Uh, in this video, I'm going to discuss about how to implement AND gate and OR gate. First, let's start with the basics. So, as we know, AND gate has one or two or more inputs and one single output. So, here I am considering A and B are the inputs and Y is the output. The combinations are 0, 0, 0, 1, 1, 0, 1, 1. If both inputs is high, the output is high and remaining 0. And this is a truth table of AND gate. So, from this truth table, we can write logical expression as y is equal to AB, and this is the symbol of AND gate. The inputs are A and B, output is Y. Now let's draw the hardware circuit of 2x1 multiplexer. So 2x1 multiplexer has two inputs and one selection input, one single output. Here output is Y. Here inputs are I0, I1. Here selection input yes. From this, the logical expression of a 2x1 multiplexer y is equal to s bar into I0 plus s into I1. This is the logical expression of 2x1 multiplexer. So, to obtain this AND gate output from mux, we need to give selection input as any one of the input of AND gate. So here, I am considering A as selection input. So here we have two cases when A is equal to 0 and when A is equal to 1. When A is equal to 0, here output is 0. So this 0, I'm going to give it to I0. When A is equal to 1, here output is same as B. So this B, I'm going to give it to I1. Now let's substitute these values and see whether we're gonna get AND gate output or not. So this is the logical expression. S is equal to what is the selection input we assumed here? So A bar. What is the I0 value? 0. Selection input A. And what is the I1 value? B. So Y is equal to this term will become 0 plus AB. So Y is equal to AB. So to implement AND gate using 2x1 mux, this 2x1 mux take two inputs that is 0 and B and uh, selection input A. So this is how we can implement AND gate using 2x1 mux. Now let's implement OR gate using 2x1 multiplexer. OR gate has two or more inputs and one single input. Here I am considering two input OR gate. The inputs are A, B, output Y. The combinations are 0, 0, 0, 1, 1, 0, 1, 1. If any one input is high, output is high. And this is a truth table of OR gate. From this truth table, we can write logical expression as y is equal to A plus B. And this is the symbol of OR gate. Now let's draw the hardware circuit of 2x1 multiplexer, and it has two inputs, I0, I1. One selection input, yes, and here output Y. The logical expression of a 2x1 multiplexer is Y is equal to S bar into I0 plus S into I1. This is a logical expression. To obtain this OR gate output from mux, we need to give selection input as any one input of OR gate. Here I am giving A as selection input. Here we have two cases, when A is equal to 0 and when A is equal to 1. When A is equal to 0, here output 0 1, same as input B. So I am giving B to the input I0. When A is equal to 1, output output is also 1. So here I am giving 1 to logic 1 to input I1. Now let's substitute these values in this logical expression, and let's see whether we are going to obtain OR gate output or not. So Y is equal to, what is the selection input we assumed? So A bar, what is the I0 value? B, plus selection input A, what is the I1 value? 1. So A bar B plus A. As per distribution law, we can write this as A bar plus A bar plus A into A plus B. As we know, A bar plus A is 1 into A plus B. So Y is equal to A plus B. See, we obtain OR gate output from 2x1 multiplexer. So to implement OR gate using 2x1 multiplexer, here we consider inputs B and 1, selection input A, and output is Y. So this is how we can implement OR gate using 2x1. Yeah, that's it about today's video on implementation of logic gates using 2x1 multiplexer. I hope you guys understood the concept. If you have any doubts, please comment down below, and don't forget to like, share and subscribe for more interesting videos. Thank you.